Okay, so welcome to another video on the introduction to mathematics. So in the last video, I discussed that 10 to the power of zero point 0.1 is equal to 1.25, and the log of 1.25 equal 0.1, and that the log of 0.1 equal -1. So that means that 10 to the power of -1 equal 0.1, which kind of obvious. So I started off with that, and the reason why I went to this because I'm using the example 10 to the power of 0.9. 10 to the power of 0.9 is 10.1 times 10.1 times 10.1, which is also the same as 10.1 plus 10.1 plus 10.1 10.1 times 10.1 times right? So this is n equal 10.1 in the same method that I used, right? Well, one section of this would occur. It would occur, right? So 10.1 plus 10.1 times is the same as 1.25 times 1.25, right? So I described this in and then when we go down, we will say this multiplied by 10.1 times, so times 10.1, so 10.1 added to itself. So the best way I could describe something like this, or the best way from what I figured out, is to multiply 10.1. So I use 10.1 because it's the 10th root. It's the 10th root of 10. So the 10th root of 10 times the 10th root of 10 9 times, and you would get the 10th root of 10 is 1.25. So the best way I could break something like this down is describing the decimal is in getting the actual decimal and multiplying it. So the multiplication, so the reason why I'm doing this is so that you'll see the relationship between the power, the logarithm, multiplication and division. So 1.25 times 1.25 is a multiplication, and then when you stretch it out, you will get 1.25 plus 2 by this, which is 250, and then you will get like 625. So, and it's a summation. So when you multiply it, you will get a summation. Based on each digit. So you will get this sum, this this summation, you'll get this summation plus 1 decimal place, and you'll get this summation plus 2 decimal place. And when decimals multiply, I think you add the decimal places. So altogether it will be 4 decimal place, right? And right, so that is the summation. Do with it there. That is the summation. That is the summation. The relationship to this. Now I'm gonna talk about something else related to this, and it will be like so 10 to the power of 0.1 equal root 10, the 10th root of 10, and then 10 to the power of 10 to the power of 0.9 is, as I described, 10.1 times 10.1 9 times, and then it'll be 10.1 plus 10.1 times, and then 10.1 times here, 10.1 times the length. So the length of the row is 10.1, and the length of the column is 10.1 times. And we describe that summation as the multiplication of decimals, right? And the multiplication of decimals. So you multiply the decimal, and it has the method used to multiply the decimal, and then something a little more into this. So when you look at division, say if you had 5 over 4, which is 1.25, multiplied by 5 over 4, you will get 25 divided by 16. So you could also describe this as 25 divided by 16. So a fraction is really just another form of displaying decimal, hemidecimal of division. A fraction is just a way of displaying division. A fraction is just a way of displaying division. And division, as you know, is a remainders thing. So 25, 1, and then it's a algorithm. So it finds the, you can't say 2 divided by 16. You could say like 2 divided by 16, and you would get the answer would technically be 0, but then you would be using the remainders rule, which is you carry the remainder over. You carry the remainder over, so you add in, so you sum in times 10. So you're carrying over the remainder decimal place, So you don't add 2 to 5 and get 7. You add 20 to 5, and then you get the remainder of you get a remainder of 4 and 5, 9, and then you add a 0. So then the next thing is 90, and you do that again, which in that case would be which would be 5.15. So division now. Division is a summation such that so let me say it's a summation of 16 that approximately equals 90. That is what division is. So a summation of 16 approximately equals 2 equals 0. Summation of 16 that equals 90 approximately equals 5. A summation of 25 equals 1. Summation. So the division is really the n in summation for multiplication at the division is really the number in the summation for the multiplication that will give the multiplication of this number at that decimal place. So depending on the decimal place of the number. Depending on the decimal place of the is not 0.15, it's 1.5. So and that decimal place. So yeah, so 10 to the power of n equal decimal place. So you're carrying over the decimal place. Right. So the next part of this, that is what I wanted to get out the way. And the next part of this is differentiating something. So I want to differentiate 10 to the power of 9 over 10 is not equal to 10 to the power of 9 minus 10. 10 to the power of 9 minus 10 is 10 to the power of 9 divided by 10 to the power of 10. You know? And when I described this, it was actually the 10 to the power of 9 summation. So 10, the summation of 10 to the power of 8 times, and then division would be 10 to the power of 10, the summation of 10 to the power of 9 times, and then the division there is simple. It's just the sum minus the sum 10 to the power of 8 minus the sum 10 to the power of 9, which you would just remain with 10. Right? So division of the same base. This is division of the same base like that. But 10 to the power of 9 over 10 is 0.9, which I just described is 10 to the power of 0.1 times 10 to the power of 0.19 times. But that's not what I want to see here. What I want to see here is that this is 10 to the power of 9. This is a second way you could describe this. 10 to the power of 9 to the power of 1 over 10, which is the root of 10. So it's the same as 10 to the power of 9 root 10. The 10th root of 10 to the power of 9. So what what so what's going on here, right? You can say, and I describe this as 1.25 times 1.25 9 times, right, for the summation. But when I describe it like this, I want to get the root of 10. So the reason why I describe it like this, because 10 to the power of 9, the 10th root of 10 to the power of 9 is the same as the 10th root all to the power of 9. So this is the 10th root of 10 all to the power of 9. This is the 10th root of 10 all to the power of 9. But if we wanted to describe this in a different way, if we want to describe this as 10 to the power of 9, the 10th root, we would say it would just be 10 to the power of 9 times 10 to the power of 9 this, the row here is 10 to the power of 9 root, 10th root, and 10 to the power of 9. The column here, if it went on further, is 10 to the power of 9, the 10th root of that. So what you can have here is what you could have here is 10 to the power of, okay, so in this one I'll just do a little research. But what I'm trying to show you here is over here 10 this 10 to the power of 9 divided by 10 is a division or a subtraction of summations, and this here has to do with the root. So this is the best way to describe it as 10.1 times 10.1, 1.25 times 1.25, 9 times, all 9 times. But if I want to describe it in a different way, we can take the 10th root. So 10 to the power of 9 is we know that 10 to the power of 0.95 is equal to 9. So 10 to the power of 9 is equal to 8 point something, right? So we could say that 10 to the power of, we could say that 10 to the power of 9 and the root, 10th root of this. I described it before by taking out the 9 and using 10th root of 10. But if you keep the 9 in, it would just be, I don't know why this computer brand new and it, okay, so this is just going to be the end of this video. So when I checked it out, if I took 10 to the power of this now, 0.9, 10 to the power of is equal to 7.2, 7.94, right? And then if I take 10 to the power of, if I take 10 to the power of 9, I will get 1 billion. So I'm gonna end off with us, and then I wanna take um, I wanna take the root of this. How to take the root of this? So let me take this now. If I take the 10th root of this, it would be 0.1, which is the 10th root, and then this now 9 thing, and then if I put it to that, to the power of 0.1, we will get 7.9. So right. We will get back, so the actual answer is 7.9, and the 10th, so right, 10 to the power of 0.9, 7.9, right? Through this method, 10 to the power of 0.1 times 10 to the power of 0.1, or the 10th root of 10 times 10, the 10th root of 10, 9 times equals 7.9, and 1 point, this is the same as 1.25 times 1.25 times 1.25 equals 7.9, which is the same as the 10th root of 10 to the power of 9. So 1 billion, the 10th root. So here is where I'm gonna use the top of this board, and this is where I'm gonna conclude this video. Right? So I'm gonna conclude this video by saying that 10 to the power of 9 is kind of like the limit of the decimal system. So 1 billion is kind of like the limit, and that is because 9 is the limit of the decimal system. So you see, 9 is the limit of the decimal system, therefore in exponents 1 billion is the limit of the decimal system. So I'm going to complete this by talking about the methods of finding the root. The methods of finding the root. So the root have different methods. If you wanted to, I saw this method. So the 10th root of 1 billion, we could say that we know, if we know the thing of 2. So let me see. This do have an advance. This do have an advanced thing, boy. Anyway, let me say 2. Let me say we know that let me use 15, and let me say 2 to the power of 15. 2 to the power of 30 is 1 billion, right? So if we know that 2 to the power of 30 equal 1 billion, then we know that it is less than 30. It was something like that I was seeing. Then you know that it's less than 30. Or you could say, I saw how it is work, I recorded not 30, but then you know that it is more than 2. Then you know that it's more than 2. You know that because log 10 so the 10th root of 1 thing billion, what is that exactly? If you convert this back to the logarithm, you will get let me see, boy. Just now, I'm gonna complete this. I'm gonna finish this off just now, but I wanted to describe this as I wanted to look at this a different way. So you know that it is more than 2, right? And then you could use like different powers. So let us say 8. Then we use 8. So let us say 8 to the power of 10, 8 to the power of 10, 8 to the power of 10 equal 1 billion. Then you know that it's a little more than 1 billion. Then you know that it is less than 8. Then you know that the root, the answer for the root, the answer for the root is less than 8, and that this is approximation. So this is how like a computer would approximate this. So to describe this is essentially the root of 10 to the power of 9. 10th root, you would see that what is the log here? The logarithm. So the logarithm, this 10 to the power of 9 all to the power of 10 of 1 over 10, you can see that what is the you can see that 10 to the power of 0.9, right? And you can see this now. Let me work this out. I'm working it out. I'm just saying, what would be the log of 10 to the power of 0.9 is equal to 0.9, right? Because it will be 10 to the this is like really advanced stuff. So I'm gonna stop there, and this is where I reach any problem. So anyway, the reason why I'm working this out is because I'm trying to show that the division, the division 10 over A divided by 10 over B is equal to 10 to the power minus A minus B. And if it's a root, then you would have to use methods like these to find the root. So I'm trying to relate the root. If, let me use this as an example, the 0.95 root of 9 equal 10, and 10 to the power of 0.95 equal 9, right? So let me say we knew the answer already. If we knew the answer already, so let me see if I could 0.9 10 to the power of, and we log this. So the log is 0.9. But in this case, you would get a negative minus log, right? You would get, because of the rules of logs, you'll get log 9 minus log 10. You will get log, you will get 0.9 minus 0.1 maybe, you might get something like that, 0.9 minus 0.1. When you because when you have division, not division like this, wait, I'm trying to figure out something here, boy. The root of using this, the 10th root of 10 to the power 9 equals 7.9, and that means that 7.9 to the power of 0.9, right? 7.9 to the power of 0.9 equal 10 to the power of 9. That's the same, right? 10 to the power of 0.95 is equal to 9, and that means that no, right. So let me start this over. If we use this, 0.9, the 0.95 root of 9 equal 10. This is another way, 10 to the power of 0.595 equal 9. So what I'm trying to explain here is log 9, log base 10 9 is equal to 0.95. This is 10 to the power of 0.95, and this is the 0.95 root of 9. So in other words, it will give the exponent power, and it will also give the root of the this is the base, so it will give the base power. The logarithm gives the base power, and it gives the, it have a number for this, you know, have a name for this, you know, and it gives the root of the number of the you would call this so this is the base, this is the exponent base, this is the power of the base, and this is the solution. So the root of the solution. If we use that, we can say that the 10th root of 10th root of 10 to the power of 9 equals 7.9. Then if we use the same thing, we can say 7.9 to the power of 10 equal 10 to the power of 9. And so yeah, that is how I revert the roots. So when you find the roots is something like a change of base. So you could use roots and change the base. So you see how I change the base here. I use 8 to the power of 10 equal 1 10 equal 10. Let me see. We could say that and this is the last example I'm going to use. We can say that is equal to 10 to the power of 9. If 8 to the power of 10 is 10 to the power of 9, then we know that the 10th root, then in this case, if 8 to the power of 10 equals 10 to the power of 9, then using this same method, we can say that because then this will be the 10th root of 10 to the power of 9. Then we know that the 10th root of 10 to the power of 9 equals 8, right? And 10 to the power of 10 to the 10th root of 10 to the power of 9 equals 8, and we know that right. So how we use it here is that we just change the base essentially. We just change the base. So if the 10th root of 10 to the power of 9 equals 8, then 10 to the power of 9 equals 8 to the power of 10. Using the same methodology. So using the same methodology, which is the change of base. So we could use roots as the change of base. And one last thing to mention here is when you're doing it like this, we know that therefore we know that we change the base like that. But if we're doing it like this, we changed the base from 9 to 8, and we changed the base from 9, we changed the base from 10 to the power of 9, we changed the base to 8 to the power of 10, we got it's really 1,072,000,000, and in that way we know that 10, we know that the root so yeah, I'm gonna stop there because I was trying to relate it to this, but we're using this method actually to, so we use this is called approximative methods, you know. And so yeah, so if we change the base like that, we know that if we know 8 to the power of 10, then we know the 10th root is equal to 8. And what we realize here now, we realize that that if then is 8 to the power of 10 equal 10 to the power of 9, and that is the log base 8 of 10 to the power of log base 8, right? So if we know this is equal to 8, then we know that 8 to the power of 10 is equal, then we know that 8 to the power of 10 is equal to 1 over 9, and that is in the log base 8 of x equal the log base 8 of x equal 10. And then when we reverse it, we know that's 8 to the power of 10. So that's powers, roots, and logarithms. And so that's it for this class and for this video. And the next thing we're going to look at is differentiation to solve roots. Thanks for watching.